In episode 45 of Mobycast, we discuss Lambda Layers, the Runtime API, and how to make serverless more modular. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Hey, welcome, Chris and Rich. It's another episode of Mobycast.
Hey guys, good to be back.
Yeah, great to have you. So, Rich, what have you been up to this week?
Oh, it feels a little bit like the quiet before the storm. I have a lot of travel coming up in the next couple of weeks, and just the way that everything has found itself into my calendar, all of the stuff that needs to happen is happening while I'm gone. So I'm trying to get things done, but when you're in that space where it's like you wish you could do something, but you can't because you're sort of blocked, and you know that by the time that everything's gonna be ready for you, you're going to be blocked again by travel. So
yeah, that's
trying to get stuff done, but I feel really challenged.
Are you at least going somewhere cool? Are you going to the Isle of Niaz or something?
I don't know what that is, and probably not that cool, but I'm going to Mount Baker to shred. It'll be my first 2 days on the mountain too.
Oh, nice.
With some buddies that I knew from back in the days at Vail who are from here. So that's going to be great. And then a couple days later, I go to a conference in Philly. And a couple days later, I have a mastermind conference in Beaver Creek. So a lot of stuff happening. And then, of course, a lot of deadlines right around there, too.
Of course. What about you, Chris? What are you up to?
Yeah, I'm just trying to get back into the swing of things after all the holidays and whatnot. So there's a fresh year, just lots of new things to look at and kind of doing some goal setting and whatnot. And then it's also when everyone else gets back, so the plate's pretty full this past week, and just dealing with a lot of just busy with just day to day getting back into the swing of things.
Right. Yeah, and Kelsys in general tends to have busy Januaries because we have clients that like to show off stuff at big trade shows and conferences. Just a shameless self-plug, we just built something for Sphero. That's their Spectrums, the app for their Spectrums new offering that's kind of making a splash at CES. And I just couldn't be more proud of the team for putting that together and seeing, TechCrunch and Engadget and CNET all covering it and talking about it as one of the most interesting things they're seeing at CES is super gratifying. So I love it. So today we're going to talk about serverless made more modular. I love. So Chris names these, and I love how he said more modular because he didn't just come out and say serverless made modular. It's more modular. So we're going to talk about Lambda Layers and the Runtime API, and basically this is kind of digging back into the pool of content that we picked up from reInvent. One of the things we love to do on this is just to really talk through some of the more complex or interesting sessions that we go to at conferences and bring them to you in a way that's digestible and in a way that gives us a chance to Mystery Science Theater 3000 it a little bit. So yeah, let's start and give us a little bit of an introduction and tell us about how you came to this particular session and what it was all about, Chris.
Yeah, so definitely, at this past reInvent, it was loud and clear that serverless is really important, obviously, and it's something that AWS continues to make big investments on and improving. And we've talked about serverless in the past on Mobycast and have done some episodes on it. We always I always like to come back to what does serverless mean? And I think a lot of people, serverless means just Lambda, and it's really a larger term than that. It's basically just if you're not managing the actual infrastructure, then we can call that serverless. So things like DynamoDB fall into this space, or Aurora serverless, even things like SQS, right, can be considered to be serverless. So it was really interesting at reInvent just to see AWS already has this huge catalog and suite of services for allowing folks to do serverless, but yet they continue to innovate in that space, and they still have a lot of work to do. So on the Thursday keynote session with Werner Vogels, that's what they kind of did a lot of these announcements around serverless. And it turns out a lot of this was around Lambda this year. So they made quite a few improvements there, ranging from announcing Firecracker, which is their new micro VM technology for spinning up essentially containers or small VMs, whatever you want to call it, but just very, very quickly and be able to handle lots of these things. So they use that now as the core platform for Lambda, for spinning up your Lambda functions. There were other improvements announced related to like just capabilities with Lambda and like increasing like timeouts from 5 minutes to 15 minutes and some other things that people may have had some issues with in the past. So it's getting more mature. And so two of the more interesting ones that they announced were Lambda Layers and the Lambda Runtime API. And these are kind of like two new foundational pieces to it that really kind of open up the programming model and make it much more flexible. So they announced that at Werner's keynote on Thursday. So after that, whenever they do make announcements for new products or services, obviously they want to keep those hidden and keep them secret until the announcement's made. So they may have sessions planned for it, but they're not going to put those sessions into the catalog until after they've been announced. And so me personally, I'm looking at my Friday calendar, and there's not a lot of content on Friday's calendar. It's the last day of the conference, and they're kind of winding down. They've gone from 5 venues to 2 venues, and just a reduced number of sessions. And I wasn't able to reserve anything, so I was kind of wondering, like, what am I gonna do?
It is Vegas.
Yeah. It's true. Although after 5 days of Vegas, it's more like, instead of like saying it is Vegas, it's like, oh, it is Vegas.
Yeah.
Right. So, but I was very, very happy after Werner's keynote, checked the app for updates to the catalog, and yeah, of course there was new sessions added based upon the announcement. So one of them was a session specifically on layers and the Runtime API. And so I immediately snagged that, reserved that, and was super happy. I also reserved one for the Cloud Map service that was announced as well. So I got to go to 2 really cool sessions on Friday. And so what we'll talk about today is just kind of breaking down what was discussed during that session about the new layers feature and the Runtime API for Lambda. Before we talk about that, just kind of another anecdote to that was, again, given that Friday's the last day of the conference, they went from 5 venues to 2. Like, there's probably like a fourth of the content available now, or maybe like a fifth. So a lot less sessions available on Friday. And I think, the expectation is, well, there's going to be less people. People are going home early. There's also, you have the big party the night before, Thursday night replay, people partying late. So they're probably not going to want to get up and go to a session. And it turns out like that didn't happen at all. I was really surprised to see, bright and early, 8:30, 9 o'clock, people were in the wait list lines, and it was just jammed with people trying to get into these sessions. So I was really lucky to have gotten reservations for both of this, for these two sessions that I was. But there were a lot of unhappy people grumbling, especially for this layers one, because the layers one was over at the Bellagio, and it was actually held as in one of the Chalk Talk rooms. Mm-hmm. And so it's this tiny room, 70 chairs, right? And so
AWS Twitter has been nonstop talking about Lambda Layers since it was announced. So you would have thought that AWS would have had more sense. Like, this is going to be a big, interesting session that everyone's going to want to know more about. So I'm surprised too.
Yeah, I mean, it's no doubt. I mean, if you had kind of put together a list of like what are the most interesting sessions at reInvent, like this is going to make the top 25 list out of the 1,000 sessions, right?
Yeah,
like very broad spectrum appeal. Lots of people are going to be interested in this. Like, this should have been this could have accommodated easily 1,000 people. And instead it was this, this tiny room with 70 chairs. And so I was breathing easy because I had my reservation. So I'm getting in, but the line of people waiting on the wait list was easily 500 people, maybe more. And then you had a few people there that were kind of just like screaming up and down the line saying, be aware, warning, like that room is only big enough for 70 people. And you could tell like the people on the wait list are like, do I believe them or not? Like, I just, like, what do I do here? And they were right. I mean, it was a very, very tiny room. It even slowed down the start of the session because the presenter he wanted as many people in there as he could get. And he saw all these folks that were interested in his talk and he wanted it in there. So he's trying to negotiate with the folks that are running the room there. Like, hey, can we like just put them against the wall or something? And they're like, nope, not going to do it. And so there was it was interesting to see this back and forth negotiation for about 5 minutes before it was like, okay, no, it's not going to happen. If there's not a chair, there's not a person. So get going.
Right. I was just thinking about the power of those people like that.
Oh yeah. And like it was kind of interesting to see like the negotiation back and forth, but like it just wasn't going to happen. So anyhow, long story short, super fortunate that I got into it, and it turned out it was a great session. It was jam packed with content. The presenter, I will try to get his name pronounced, Danilo Poccia. And he's a principal evangelist in the serverless group there at AWS. And he did just a wonderful job. Lots of good content, but also gave a lot of really great practical tips. So we'll dive into that a little bit here and just break down that session.
Cool. Yeah. So this was specifically, it was SRV 375 in case people are trying to find it on the internet, because some of them are on there.
Yeah. And this is, if you are interested and want to get the full session, it's the video recording of the session is on the YouTube channel, the AWS YouTube channel. And then they've also published the slides for this as well on the SlideShare. So I'm sure we can have links in the show notes here for both those, but they are available.
Great. So yeah, let's get into it.
Yeah. So Danilo started off first just talking about, his two main pieces here, Lambda Layers and Runtime API. So first went into Lambda Layers. So we can talk a little bit about, what they are and, why they're useful. So, I'm sure most people know Lambda, it's a function invocation platform. So it's a way for you basically have some code. It's packaged up as a function. You upload it as a zip file to the Lambda service, and then you have something that triggers the execution of that. And so then when it gets executed, it's now reading in your code that you had uploaded, that it's executing that function entry point, which again can call other functions and whatnot. But the gist is you've packaged up your code as a zip file, you've uploaded it to Lambda. It's now invoking that on demand, executing it, and then the results are returned back to it. And so some of the challenges that come with that are, if you have a very simple function like in JavaScript with no dependencies, then it's pretty simple to go ahead and do that. But, what if you want to run code that uses, 5 other packages, or it has these other dependencies that have to come along with it? It could be that instead of just one file, you need 500 files that are all that zipped up and sent up to Lambda. You need that. That's the runtime support that you need for it. It gets even more complicated, right? If you actually have binary dependencies. So if the code that you are running, maybe it has some packages that for various reasons, maybe performance or other reasons.
My favorite one is Image Magic for this example.
Sure. Yeah. Image Magic, great one. So the Image Magic, C++ code, there's going to be bindings there to go from your dynamic language to Image Magic, so whether you're calling it from JavaScript or Python or whatnot, there's going to be some compilation that needs to happen in order for those bindings to work. So, there's some additional work that you have to do as a developer to get that compilation done and then zipped up, and that becomes part of your zip package, right, that you upload to Lambda. So up until now, it's been a very, isolated process where you have to kind of do the exact same thing every time across all your functions and across all your teams are kind of having to do the same thing, right? There's no way to really kind of share or to build on maybe these dependencies that you have. And so that's exactly what Layers allows you to do. It really is just a layer of files that you can stack on top of your whatever runtime you're using. And you can have up to 5 of these layers, so however many layers make sense to you. But you can kind of think of it as just they're really useful for sharing dependencies. For if you're doing some more complicated packaging, again dealing with things like binaries or whatnot, you can do that once and store the results of that in essentially a layer. You just have to do it once. And now you can have that as a reference. And then you can now, whatever is now different about the particular function or the particular code that you're doing, you can just reference that as like a reusable component, if you will.
I just wanted to make that more explicit with an example. And I don't know for sure if this is a correct example, but I'm going to try it and we'll talk about it. So going back to my Image Magic example, I can imagine you having a function that lets you upload an image and stores it somewhere. But on the way to storing it, it's got to do something with that image, maybe crop it or maybe downsize it or whatever. And that's something that ImageMagick could do. And then it goes and stores it somewhere, S3 maybe. And then another function that goes and gets images custom fit to a certain size, like maybe that all have to be square. And they've got to be, 600 by 600 pixels or something. And so that function is going to grab the image out of S3, run ImageMagick on it to crop it just right, and then return it to the user or return it to the caller. And I'm thinking that would be an opportunity where you could create a layer that has some code in your, language of choice. Maybe it's Node, maybe it's Ruby, that talks to ImageMagick and uses it to do the job that it needs to do. And that code would be used across both of those functions for both the create of the image and the get of the image. And so if you could put that code into a layer, you wouldn't have to put it into both of those packages. Is that a good example?
Yeah. So you in this particular case, having a layer just with ImageMagick.
And maybe a little bit of interface code between your language.
Sure. Yeah. I mean, you may have like a common library that kind of has an abstraction that's built on top of ImageMagick.
Right.
The way that it invokes it and executes a certain API and gets back the results or whatnot.
Right.
So that whole thing might be like a good candidate as a layer, because it's probably pretty complicated to put. There's a build process associated with it, right? You have to go and make sure that you're building that code essentially on an AMI that is the same that Lambda uses, right? Like you can't compile your code on your Mac and then upload it to Lambda. Not going to work very well. So there's work associated with that. And so if you do that as a layer, it's now a reusable component that you don't have to worry about anymore. So now you can just focus on what's different. So now you have that one layer with this shared library that provides the interface into your ImageMagick functions. And now you don't need to worry about that anymore. It's going to be there for that function. So the function can just make the call into that shared library, and it doesn't have to be part of its layer. It just because it's part of the previous layer that was put in there. So that's a great example for when this really, really shines.
I think it's fair to say, just talking that through, I think it's fair to say that without some additional help, there's more heavy lifting involved in doing that than there would be in, say, making ImageMagick a dependency in maybe your Express app and just having a whole app that provides both the create and the get features, APIs. So even though we get layers now, and that layers help us not have to do all the dependencies for each Lambda function, it's still technically, it's just like less work to build an application than it is to build a whole system one function at a time inside Lambda. You see what I'm saying?
Yeah,
right?
Yeah. I think we've touched on this in the past too when we talked about serverless. Is that it's definitely it's a different model. You have to structure your code differently. You have to think about it differently, and so everything changes, right? Like CI and CD change, the way that you test these things, the way that you build these things, the way that you package them, the way that you deploy them, the way that you invoke them. It is quite different, which makes it actually a lot more difficult to adopt something like this than even something like containers, right? To go from VMs to containers, your whole programming model doesn't have to change, right? Some of your process stuff is going to change, but it doesn't require, it's the mental shift there is something that you can probably assimilate within a few days and then refine it from there, versus serverless kind of really makes you think about things quite a bit different. And even though it's been out, like Lambda itself was launched in 2014, I believe, so it's been around now for 4+ years. It's not like this robust, mature platform, right? There's still a lot of work to be done. Just like we're just now getting layers.
Right.
And we'll talk about more about like this actually opens up a whole bunch of other holes that like AWS has not yet addressed, and they'll need to at some point. So
I bring that up largely because I'm just imagining there may be some people listening. You may be out there listening and saying, I have every plan, and our CTO or I'm the VP of technology or whatever it is, I have the plan to build our application on serverless, and I'm going to go for it. And Layers is going to make it easier for me. And I will say that, it's technically there's more things that have to happen. One thing we haven't talked about is just that as part of doing this, there are some tools out there. The one that I'm familiar familiar with now is called the serverless framework. And the serverless framework, what it does is basically lets you treat your local system. So, wherever you're doing your development, it lets you treat where the files are on that as kind of your framework for application development. And then it's able to translate that into, okay, well, these files are here, those files are there, these files, and I've got a little YAML to tell me where everything's supposed to go. I can pretend like this is an application, like a classic application, like an Express application or something. But in reality, I'm going to go do a ton of CloudFormation work to go deploy these behind the scenes that you don't have to really deal with. So the development process can actually feel a lot like it does currently for regular applications. And I do think it's worth, taking a look at those. I think that they've done a great job of making Lambda development feel like, Express Node.js development. So worth taking a look at. But know that underneath all of that, a lot of stuff is happening. And whenever there's a lot of stuff happening, there's a lot of places where things can go wrong, and you have to learn and be able to troubleshoot, et cetera, et cetera.
Yeah, absolutely. So there, and like you point out, I mean, there's definitely some great tools for developers for developing. There's I think it used to be called SAM Local. I think it's now SAM CLI. It might be the same thing that you're referencing with the framework. Mm-hmm. So definitely, and you can run Lambda locally, right? So
right. Essentially, if you're developing a lot of serverless stuff and you're in the console, like clicking around in there, you're probably doing it wrong. Like there's better tools than that.
Yes, absolutely. And I think going back to your original point of like layers don't actually make like serverless easier.
Right.
They make it better and more modular, and allows you to use some of the engineering techniques that you're used to, but it doesn't actually make anything easier per se.
Right. I think the best example of making it more modular is just, now I've got to go change something that's sort of a dependency. Oh, and look, these 11 functions use that dependency. Well, now you get to not have to go change those 11 functions. You can change your one layer.
Mm-hmm. Yeah, so maybe we should talk a little bit about just the layers themselves and how they're created, how you use them.
Okay.
Some things to keep in mind when using them and whatnot. So layers are really kind of no different than the way that you kind of currently use Lambda functions. So you're basically packaging up a set of files into a zip file. That zip file is your layer, and you upload it to Lambda, and now it's available to be referenced by a Lambda function. And so Lambda functions can reference up to 5 layers, and you specify the order in which those layers are installed. So something to keep in mind with these layers is that layers don't have no knowledge of other layers. So you can't build on top of a layer. So I think a really good analogy to this would be Docker images. And so Docker, has the concept of a base image, and then you can extend from that base image, right? And then from there,
keep adding packages and features,
right? Or even delete from it, right? And then just going from there. With layers, you could do that, but you'd have to do it all manually. You'd have to manage it yourself. Because again, at the end of the day, all it really is a zip file. And what Lambda is going to do is Lambda is going to unzip that zip file into a very specific path. They're all going to be extracted to the same. Every layer that you use is going to be extracted to the same path. And so you need to make sure you understand what these layers are doing and the coordination between them, because if they can override each other, right? So if you have a conflict between 2 different layers where one has this version of the file and the other one has that version of the file, it's going to come down to order of extraction based upon how you listed the order with your when you reference these layers in your Lambda function on last write wins. So it's something to be aware of, and something you're just going to have to keep track of that yourself. And so you probably can come up with, with your own internal process where to create the layers themselves, you can kind of do an inheritance type approach where you have a base layer, if you will, and then you can then add to it. But you would have to provide the tooling and the process for kind of, that's how you build your zip files.
You said something that made me picture something that I want to try to say and see if it feels right. So if I'm developing a regular old app, not a Lambda function, but just like say Express or Ruby on Rails or Sinatra or something, I may have a folder in there that's like, database objects, and maybe in there's stuff that talks to the data that kind of translates between the database and the code. And that stuff may be used by lots of different controllers, let's say. And those things would reference those database objects via just the path that they're in. That, if you import them, you just have to be like, / database objects and then the name of the file. Like that's how you talk to those other files from your code. And the way it all works is just by the virtue of the fact that the files are where they're supposed to be on the file system. And what it sounded like you were saying to me is that Layers essentially works the same way. I'm just going to unzip this and dump the files wherever, dump the files here. And that's sort of an agreed upon convention that I know where I can access those files. Like maybe there's a folder called /layers or something. So I know I can say like layers.whatever or, import layers / whatever. Is it kind of that way, like where I just pretend like the stuff in my layer is like just stuff in a folder that I can import from my code? Because the other way of doing this would be like, it creates a shared library, and that shared library is a binary, and then you can talk to it through some other sort of code mechanism. But to me, it's sounding like you're saying it's just code that you can call and import into your current file or class or whatever you're working on module.
Mm-hmm. Yeah, in a way, like it's not too terribly advanced.
Right. That's what I'm trying to help people understand is like, this is just pouring the files into somewhere where you know where they are. And it's doing that for every function.
And another way of thinking of this is that like in the past, it was if you have a Lambda function, you upload a zip file, right? Mm-hmm. And it's one and only one zip file. Mm-hmm. Now with Layers, they're just saying, you know what? You can do this in up to 6 zip files. Mm-hmm. And we're just
functions can see some of the, up to 5 of those zip files without you having to upload them again.
And again, all it's really doing is just Lambda just says, okay, go pull in the zip file, extract it to this directory. Mm-hmm. Is there another one? Pull in the zip file, extract it to the directory. So Lambda doesn't care. And it's like, you can do whatever you want with it, right? Like you could have like each zip file is mutually exclusive and it's talking to different parts of the file system. It could be that they're all talking to the same path and it's overriding, but it gives you a way of packaging things into reusable components. Mm-hmm. But the underlying technology, it really is just like zip file, extract, zip file, extract.
And then to talk to the layer is the same way of talking to code that you're already used to. I think that's the part that I'm getting at that's maybe sort of subtle is like when you learn a programming language and you want to go access some functionality from a class or module or something that's in another file, you typically have to do something like import it into the current file that you're working in. And what I'm trying to help people see is like, that's all Lambda Layers is providing for you. It's like, you can picture it as though it's your same actual computer and like you can access those other files just the same way you normally would. You don't have to, that's what it's also kind of a question, right? There's no magic you have to do. You just, those things are available for you.
In fact, your Lambda function that, when you have your Lambda function, you specify, it uses these layers. That's the only linking between it. Your Lambda code is just going to expect that those files are there, right? Okay. You're not going to see anything in your, like, you won't necessarily see specific, like, I'm going to inherit or I'm going to import or whatnot. You would just do it the way that you would normally. So I guess a good example would be like, if you have if you're writing a program in Node.js and maybe, you're using NPM to manage some dependencies. And let's just say like for whatever reasons, you have like just a common set of dependencies that you use for your Node apps. And so maybe it's a list of 20 dependencies. So that's part of your base layer, your underlying layer that you create. So you have a package JSON file with 20 dependencies in it, you npm install, that ends up you package that as a layer, you upload it. Now you have your Lambda function, and maybe it has to use Lodash or something like that. But Lodash is in the common layer that you just created. So in that code, like you may have a package JSON to list like some other 2 or 3 dependencies that it uses, but you won't see Lodash. Yet the code itself will be able to basically just require Lodash kind of like auto-magically, and because it's going to be there on the file system as if it had been installed by npm, because you did that in the previous zip file layer. So So it's kind of, again, it requires you have to keep track of like what are actually in your layers. Like, what are you expecting to be there? And so in that sense, it's a little brittle, right? Because you have to manage that. And, maybe something else along these lines of the brittleness is that, you can change layers, right? You can version them. So you can say, okay, this particular layer, like maybe some dependencies have been updated. I'm going to go ahead and create a new version of it. So now I have version 2 of the layer. But maybe you have like 500 Lambda functions, and those 500 Lambda functions use the V1 version of it. So what do you do now? And so you can delete the old version, but as long as there's other Lambda functions that are referenced in it, it's still going to be kept around. You just won't be able to use it for any new functions. It won't show up in the list of available layers, but it's still being held in the background. So you start running into these just management issues of like some questions like, well, how do I know what Lambda functions are used in the old layer? Like there's no easy way to figure that out right now. Like that's a missing piece. Again, this is something that you're just going to have to like just deal with yourselves and figure it out. So I think
that's a really interesting thing, though. Like I was just thinking about, well, what does happen when you update a layer? And I think in my first mental model that I created of layers, when I was trying to think of it as super, super easy, I was imagining that even though you have this shared code, that whatever behind the scenes in Lambda is managing this is literally pouring out the layers into each and every one of your functions. You just get to treat it as though it's one thing. But now when I think about updates, I realize that whoever implemented Lambda is probably not wanting to go do 500 updates on 500 different Lambda, instances. So maybe they do something more like using EFS or something to basically say, hey, this is where your layer lives, Firecracker VM. So now I can go change that under the covers and voila, you've got a new version without having to do it 500 times.
Yeah, I mean, layers are just a file, right?
Yep.
And so they're probably stored in S3, almost guarantee it. They're stored in S3, and they are associated with, they get an ARN, right? And this is how you reference them by their ARN. So yeah, so from that sense, like there's no correlation between the running functions and that. Like what Lambda is doing is just saying, okay, I need to go and create a sandbox for this function. Does it have layers? Yes, it does. Okay, what are those ARNs? Look up the ARNs, figure out where they are, retrieve the zip file, extract it to the directory. Now I can go do the same thing for the Lambda function itself and then go and execute it. And as long as it can find that ARN and do that, that's what it's going to do. So and that ARN is tied to that whatever version it was whatever you specified for that function. So when you go and create a new version of your layer, as far as Lambda is concerned, it's just another ARN. It's just another resource, and it's not tied together to the other one. And that's what this problem is, right? That's why you can't. It's not going to automatically update your functions, and you probably don't want that either, right?
Right. Yeah. If you have a long running function, it's in the middle of running. You don't want the world to change underneath it in the middle of running.
And then you also may not want to push out, like for various reasons, like some functions, they may very well be able to handle a new version, but other ones, maybe they would break.
Right.
Right. So it's definitely probably without a richer ecosystem, it's the right thing to do, but it puts more of the burden on you, and is something that you're just going to have to manage.
Got it. Makes sense.
Yeah. Maybe another limit just to be aware of is that the storage space with that is applied towards the same per region limit for Lambda function storage space. So that's 75 gigabytes. So that means the total storage space for your zip files that you've uploaded for all your Lambda functions and all the layers themselves can't exceed 75 gigabytes per region.
Okay.
So something to keep in mind there.
Easy enough to just create a Lambda function that creates a new AWS account and then moves the storage into the new account.
Yeah. I mean, and that's really the workaround, right? Is like if 75 gigs ends up being something you need more than that, then you're gonna have to create layers in either other regions or just probably even easier, just other accounts.
Right.
Maybe some other things that we can talk about with layers are permissions. And so again, at the end of the day, layers, they get an ARN. They use IAM for permissions and security. And so you can use the layers within an AWS account. You can share layers between accounts, or you can also have layers that are publicly shared. So they're open to the world, which is, it's kind of the beginnings of the potential for like a layer marketplace, if you will, right?
Yeah.
But it doesn't, this is another thing that's kind of missing, right? Like there's no infrastructure to support that. So if you do have a layer that you want to make public and you want to share it with the community, you have to publish the ARN for it, right? And people have to know what the ARN is. And that's the only way that they can see that, right? There's no repository for layers, right? There's no marketplace. So
I've got my VC on the phone, right?
Yeah. So absolutely, it's one of those things where, man, it's going to happen, right? I'm sure AWS will build something, but who knows when that will show up. But this is definitely something that is sorely needed right now. AWS did announce they have started that. They've kickstarted that. They have an official pre-built optimized public layer that they're publishing that will be available to the community. And that layer includes the NumPy and the SciPy packages. So popular packages used like with Python to do machine learning, data science type stuff. They're usually difficult packages not difficult. It's just they require work to set up, install, compile, and whatnot. So now there's a layer that has that, so you don't have to deal with that. So if you're using NumPy or SciPy in your Lambda, it's now super simple to get going with that. You just reference that public ARN for that layer in your Lambda code.
I love the fact that they're optimized too. Like you just know it's going to scream on AWS because they optimized it for you.
Yeah, indeed. And then, we've kind of already talked about just the mechanics of building a layer. It's really the same process as what it is to make a Lambda function. So you have your files, you do whatever you need to build those files and artifacts. And then when you're done, you zip it up, and then you can go either to the Lambda console, or you can use there's new APIs, AWS APIs for doing this, for creating that layer, registering it with Lambda, and uploading that zip file. So pretty simple, pretty straightforward, pretty expected. And
cool.
that is layers. So after that, the second half of that talk was all about the Runtime API. The Runtime API, this is what opens up the flexibility for Lambda so that you can now it gives you the ability to have any language supported in Lambda. So up until this point, before this was announced, there were certain runtimes that were supported by Lambda, and you had to use one of those, right? So Python, Java, Node.js.
The notable lack that everybody was complaining about was Ruby, which is kind of funny because of all the developer communities out there. I think the Ruby one was most interested in Lambda and serverless with Lambda.
Yeah. And so that was one of the announcements that they made, that Warner made in his Thursday keynote, is that now Ruby is officially supported as Lambda execution environment. And they actually did that via the Runtime API, right? But it's just baked in now, right? So now you're able to choose Ruby as your runtime environment for your Lambda function. You don't have to build a runtime API. You don't have to build a custom runtime for it. It's directly in the platform. But this Runtime API, it's a very kind of simple, straightforward interface that gives you the capability for building whatever kind of runtime you want and run it in Lambda. So if you want to run COBOL code, you can do that. If you want to run Rust, or if you want to do Scala or Erlang, whatever, or PHP, right? All these just opens up any kind of language that you want to do.
And it sounds complicated. Like there's something about the way they named it, or just the fact that it's AWS, or something that just makes you feel like, ooh, that's hardcore. But the reality is you already know how to install those languages on your computer or on your virtual machine. And now we also know that Lambda is running its stuff on Firecracker, which is a little mini VM. So if you imagine, how can I make it so this little micro mini VM can run a new programming language? If you were able to just log into it and wanted to do that, you would know exactly what to do. So from that perspective, it's like, oh, this isn't rocket science. This is just installing, essentially like a a language's interpreter or compiler or whatever, runtime system onto that micro VM.
Yeah, I mean, that's definitely a big part of it, right? Is the whatever runtime support that particular environment needs. And then, the other part of this is like, okay, how do you integrate in with Lambda? And that's the whole runtime API, right? So there needs to be this interface between Lambda and your custom runtime so that they can basically do the back and forth, the handshaking, right? So there's a certain sequence of flow events that happen. So like, the first step is, an event comes in, have to do things like get the tracing ID. There's creating context associated with that. Then you actually invoke the function. And then after that, you have to handle the response and handle any errors, do the cleanup and hand that back to Lambda, right? So there's this back and forth flow coordination between the Lambda platform and the runtime environment.
Right.
That's the bulk of the work here, right? Is, it's one thing to go and basically install PHP. You got to do that. And you got to make sure that that's the way that it's optimized and it's installed correctly and whatnot. But now you have to provide that interface that Lambda knows how to call you, and you're implementing that interface that it's expecting, right? Okay. And I think the first half of that loop is probably the easier part of handing off a request and invoking, having the function run. Probably the more difficult part, depending on your whatever runtime you're supporting, is making sure that you're actually handling all the error cases. How do you trap those errors and the response, and making sure that all gets caught correctly, packaged up, and then sent back into Lambda, right? That can get trickier. So, I mean, just think about languages like Node.js and just the way that it handles errors, and how do you catch uncaught exceptions and everything else. I mean, it's not rocket science, but it's not like just super simple, right?
So, a great little example. You brought up Node.js, and one of the things that's kind of weird about Node.js and Lambda is like, you can return an error or you can throw an error, and like Lambda knows how to handle that. And I think whoever implemented Lambda's Node capabilities had to make a decision. Okay, what am I going to do with a thrown exception versus a returned error? Mm-hmm. Yeah. So for any language you implement with the Runtime API, you've got to think about that stuff.
Yeah, absolutely.
Nobody's going to do that, right? Like any language you want is probably already there. Like already there was like COBOL and Ruby and PHP. And then, since then I've seen announcements around Rust, Haskell. I think I've seen Lisp. Mm-hmm. So unless you're implementing your own, and that could be the case, like maybe Salesforce has its own proprietary language, and maybe they want to put some stuff on Lambda. They could do that for their own proprietary language, Apex. Mm-hmm. So, or if you're a big company with your own language and you want to use Lambda for it, you can do it.
Yeah. There's been a lot of good work already been done by other folks in this space. So like if you want to run C++ in Lambda or C, that exists now. There's that custom runtime has been built. Same Rust, COBOL, PHP. Yeah, and it's just growing. So, but I guess the important takeaway is that the Runtime API has enabled that. And so now it's just whatever language you want to do Lambda in, you can do that.
Cool.
Yeah. And then maybe just to finish up, there was a couple, again, mentioned that Daniel led, again, great session, did a good job presenting a lot of content pretty quickly and concisely, and then also kind of sprinkled it with some tips and things. So just wanted to follow up with a few pro tips that, came to light during the talk that I thought was kind of interesting. So, and they're all kind of really around Lambda, having Lambda functions and whatnot, but it may be things that people are not necessarily aware of. So, one thing that was kind of interesting is that, so when Lambda runs, your functions runs, it has a sandbox that runs in, right? So, I mean, let's just keep it super simplistic and just kind of like pretend it's like a VM that's spun up, right? That your code is running in. Lambda then gets the option of deciding on whether or not to keep that sandbox or to tear it down or to assign your function to another one, right? So there are a lot of scenarios where your function repeated calls are going to be running on that same sandbox. So that means that, if you've written to /temp, whatever you wrote to that on the previous function call, like that's going to still be there, assuming that you're still running on the same sandbox. So this is a technique that you can use. Like if you wanted to have a very quick, very easy, quick way of caching stuff, you can use /temp in the file system for your Lambda functions as a cache. But just realize like it could be pulled out underneath of you at any time. So you definitely want to have a way of rebuilding or not relying on that being there. But you can take advantage of the fact when it is there.
That's cool.
And similarly, same thing goes for global objects. So if you have global objects in your Lambda function, they will persist between invocations as long as that your Lambda function is running on that same sandbox.
Oh my God, I hope somebody's in the middle of like a 2-week bug tracking down session and hears this and is like, oh my God, that's what it is.
Yeah. So to kind of like those ephemeral issues to keep in mind about just how it actually works underneath the covers. And then a practical tip, Daniel kind of suggested, 2 to 3 layers at most. Don't use the full 5. There is a performance cost of this is sequential, right? So when your function is invoked and you have a list of layers, it has to do that. It's going to do that sequentially and it's going to do it serially, right? It's not going to be done in parallel. It's going to be done serially. So it has to extract the first layer, wait for that to be done, and then will it go extract the next one. And then until it actually gets to your function and it extracts that one and then it's done and ready to go. So
wait, seriously? So your function gets invoked and it's got to unzip as many as 5 files in order to even invoke your function?
If you have 5 layers associated with that function, yes, absolutely. Yeah.
That can take a long time.
Well, it's up to you. I mean, it's really just, how long does it take it depends on how big your zip file is. Like,
it could take in the order of seconds, I'm imagining.
It could perhaps. Yeah. So definitely, you definitely want to keep it in mind. I mean, it is true that, usually once that sandbox is initiated, as long as it's being regularly invoked, like the odds are good that you're not going to have that startup time again, because it's going to be able to reuse sandboxes. But again, no guarantee. So
I literally saw today on a Slack that I'm on, somebody was asking that exact question. He was like, yeah, I'm doing this toy function running Lambda, and I'm trying to get rid of the spin up time that's going on. Does anyone have a good low mental overhead suggestion? And, the answers were kind of like, yeah, you can kind of do some stuff, but it'd be better if that's a problem for you, it'd be better to not use Lambda.
Mm-hmm. Or just, make your Lambda function simpler. So like, this is why a lot of times, like, if that's a kind of a concern or issue, like usually Java as your Lambda function environment is susceptible to this versus other languages. And it's not necessarily because Java is slower, but it's just typically Java, the way that it lays out its code and with class paths and whatnot, it ends up, there's just lots of files, right? And it's a bigger zip file.
Yeah, and these people were saying, if you're on Node, we've seen Python's a little faster.
Mm-hmm. Yeah. Or, something like Go is like, if you're really concerned for performance, something like Go is probably a really great choice. It's compiled and it's definitely lower level, much smaller in file size as well. So,
right. And then some people were also saying, and I love reading this actually, some people were saying, the next simplest thing, if you've got kind of one function that you need to get done, we're liking moving these to ECS tasks when they're not fast enough for us on Lambda.
Yeah, I mean, it just depends on like what it is that you're doing and how often it's being invoked. So, we've talked about ECS quite a bit in the past on this podcast. You can have things that are constantly running. You could have things that are, you can easily invoke them based upon events and just have a task do one and done. You can have scheduled tasks.
Right. And I'm just guessing it would be quicker to spin up an image and run a function on it than it would be to unzip a bunch of files and then run a function on it.
Yeah. I mean, it depends. I think like theoretically, Lambda has the potential to be faster if you package it right. And if you do things like, you may have to do some warming.
As soon as you get into warming though, it's like, oh my God, I'm working against the tool.
Mm-hmm. Yeah. I think that's one of those things where I don't think there's like a clear cut answer to say like it's Lambda versus ECS. Mm-hmm. Lambda has Firecracker now, and ECS doesn't, and it's going to be a while before ECS gets that. Although Fargate will probably be the first one that gets it.
But to explain my reasoning, like the reason I was thinking a cold start on ECS might be faster than on Lambda is because today I learned that, you get the Firecracker thing spun up and then you have to wait for any layers or other things to get unzipped and sort of laid out into the Firecracker. And then now I can execute it. Whereas I think with the Docker image, you just spin it up and go. Like the file, everything you need in the Docker image is there and ready to be used.
Yeah. I mean, in both cases, you have to have the VM, and then you're now bringing up your execution environment. So, on ECS side, that's your image, and creating that container within that VM on ECS versus, and that is just, it's already pre-built, right? Which is kind of what you're getting at versus on the Lambda side, it's not one image pre-built, right? It is this file. It's basically a file system, right?
Right.
It's a collection of files. It's a file system. And again, so if you have lots and lots of files, then it's going to take time to, unzip those and to write them to disk. And if you have multiple files, then of course it's going to take even longer. So, potentially, it depends on like how big your zip files are, how many of them you're using, how long does that take? And, does the two platforms, like what's the trade-off between them? So it would definitely be just looking into the specifics of it and see, if you're on Lambda and it's not working as well for you as you want, like, are there easy things that you can do? Maybe you're doing some things that you really shouldn't be doing, and you can make that run better. Or it could just be like what you're trying to do. Like, you really should package this up into a Docker image and run it as a container. You're going to be
right, and have an ongoing service or something. Yeah, sorry for diving so deep on that. I just, if we have any listeners left, that for me was the biggest thing I learned today. Is just like for some reason, I thought that Lambda functions were just like kind of like images, like turn on the image and go. And now today I learned that they've got a little work to do before they're ready to rock.
It's just a collection of files. It's a file system. Is all it is. Yeah.
Great.
It's like a USB stick.
Yeah, I know. It's wild.
Yeah.
Well, thank you, Chris. And thanks for putting this together, Rich.
Thank you. Thanks, guys.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/45. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.